This is an example of a Poisson distribution problem. The computer help desk receives an average of 4 calls per hour for assistance, and we're going to randomly select an hour and answer the question, what's the probability of 7 calls in that hour? This is Poisson because we have some occurrences that are happening over an interval of time, and Poisson has occurrences of things happening over intervals of time or distance or area or volume. There is a known average number of occurrences right here happening over the interval, and the occurrences are happening independent of each other. And so we're going to assume this is a Poisson distribution and use the Poisson to answer this question. Now, when you see the word average number of occurrences up here in the question, then that symbol for the average is a Greek letter lambda. And so right here, the 4 calls per hour, the 4 is the actual lambda. So lambda is the average. And then we usually use the symbol X for the number of occurrences that are in the question that we're trying to ask the probability about. There's a formula in your textbook that you could use to answer this, but I'm going to show you how to use your calculator. It's a Poisson distribution, so we'll be using this key right here. It's a second function key, so you tap second and then vars, and then you'll have to take your down arrow and come down and find the Poisson PDF. There's a CDF which we'll use in a minute, but we want the PDF. So make sure you're on the Poisson PDF. You will enter. And then some of you, your calculator may show a screen right now that looks like this. If so, after the parentheses, you put in the average or the lambda, then you use your comma key. The comma key on your calculator is right there. Then you would want to put in the number that's in the question, and then you would touch the enter key in the lower right hand corner. For those of you who have a calculator that looks like mine, you put the lambda right here. So I'm going to type the 4 in. You come down, click down 1, put the 7 in, click down to the word paste and enter, and then you'll have to enter one more time. At this stage, those of you who have a screen that looks like this should look exactly like this. The answer should look the same. So when there's an average of 4 calls per hour, then the question, what's the probability of 7 calls in an hour? Then we would say it's about 6% chance of there being 7 calls in an hour when the average is 4. Now let's change the problem a little bit. We're still going to use an average of 4 calls per hour, and we're still going to select an hour randomly. But what if we want to know the probability of at most 6 calls during that hour? At most 6 would mean that there's no more than 6. 6 is the most it could be. And so we're answering this question, x less than or equal to, sorry, that should be a 6 there, not a 4. That's the same as asking 6 calls or 5 or 4 or 3 or 2 or 1 or none. So you could use the Poisson PDF, and you could put a 6 right here where we did before. You could put a 5 in there, then a 4, then a 3, then a 2, then a 1, then a 0, and you could sum all of those together. But the calculator has a cumulative distribution on it, and you can find it by touching second, vars, come down to the Poisson, but now find the CDF. Oops, it went too far. Right here, Poisson CDF, and enter. And again, some of the calculators will look like this. And if so, you want to type in your average first, your lambda first, and then you want to type in this number. And what the CDF will do is it'll put in the 6, and then it'll do the 5, the 4, the 3, the 2, the 1, the 0, and it'll accumulate it all for you in one big step. So on my calculator, I'm going to put my lambda in, which is 4, that's your average. And then I'm going to put the 6, which is the endpoint that I want. Then I'm coming down on paste and entering. And then I'll enter one more time. And then if you had this, you should get the same answer. The Poisson CDF, again, accumulates from the number that you give it downward. It's like doing separate PDFs and then adding them together, but it starts with the number you give it downward. So if the question had asked something like, what's the probability of more than let's say more than 8. So you're asking this question, more than 8. That would be like 9, 10, 11, 12, that direction. You're wanting it to go. Good one. 11, 12. You're wanting it to go that direction. You would have to do the complement of this because we don't have anything that accumulates going forward. And so what we would have to do is we'd have to write in 1 minus, and then we'd do the Poisson CDF. You'd put in your average, your lambda, but we'd have to put an 8 right here because the opposite of 9, 10, 11, 12, 13 is 8, 7, 6, 5, 4, 3, 2, 1, 0. So that's what we want it to do, and we want it to calculate that, and then we do 1 minus that to get the complement. So I'm going to do 1 minus, I'm going to go second, distribution. I'm clicking down till I find the Poisson CDF. I'm going to type in 4, and I'm changing this to an 8, and paste, and then enter. And then there's about a 2% chance that there would be more than 8 when the average is 4. The other thing that can commonly happen in a Poisson question is that they can give you the average, like they have been, 4 calls per hour. And then in the question, they ask a question where the time interval or the distance interval or the volume or whatever has changed. So this question is, what's the probability of 9 calls in a 2-hour period? When the question changes the interval, you have to adjust the lambda. And so what we would do here is we would readjust the lambda and use it. So this is the adjusted lambda. And if there's 4 calls every hour on average, then that would mean that there would be 8 calls in a 2-hour period. And so we would use the 8 as the lambda in this question. So the x here would still be a 9, but the new adjusted lambda would be 8. And then you could go ahead and use your Poisson PDF on this one because it's asking about an exact amount. You'd put your new lambda here and the question number there. And so let me go to mine and second distribution. I'm going down to the Poisson PDF. I'm putting the new adjusted lambda in here. It's 8. And then the question is asking about 9 calls. Going to paste and enter. And then enter one more time. About a 12% chance that you get 9 calls in a 2-hour period when the average is 4 calls per hour. So sometimes you have to adjust the lambda. When we changed the lambda from per hour to per 2 hours, that was pretty easy. But sometimes they might give you something that's a little harder to adjust the lambda. Like this question is, what's the probability of 6 calls in an hour and a half? If that's the way the question is asked, you can sometimes set up a proportion that would help you. So it's 4 calls in 1 hour, and then you're trying to figure out how many calls in an hour and a half to get your new adjusted lambda. If you set up the proportion and you cross multiply, you take 4 times an hour and a half, and then you divide by whatever is across from here, which in this case is just a 1, so that's not as bad as some of the questions that are in the textbook. So you're going to go 4 times an hour and a half, and then divide by 1. That'll give you your new lambda on that question. And so the new lambda is going to be a 6. It's 6 calls per every 1.5 hours. So the new lambda is 6. So when you come over there, you could use your calculator to answer questions at that time. The one we just finished, it was easy to switch from per hour to per 2 hours. Sometimes the questions in the textbook make it a little more difficult, like they might change it to an hour and a half. And so it may help if you set up a proportion to get your new lambda. So like if you do 4 calls per 1 hour, and then you're trying to figure out how many calls per 1.5 hours. When you set up a proportion, you can cross multiply. So you take 4 times 1.5, and then you would divide by the one that's across from here, which in this case is an hour, so it's not that hard. But you'd take 4 times 1.5, you'd get a 6, and then you divide by 1. And so the new adjusted lambda is 6 calls per 1.5 hours. And then you could go ahead and answer this question, the 8. And so I'll just quick do this. You go second distribution, and you go down to your Poisson PDF. And the new lambda now is a 6. And then the question is about 8 calls. And then come down to paste. And it's about a 10% chance.